next speaker is Josh Barron from DARPA, and he's going to talk about DARPA and privacy research.
Okay. Thanks for having me. This is a really weird talk for me to give. Well, first of all, because I'm definitely not going to give a talk about differential privacy. Frankly, the primary reason for it is essentially everyone that I'm funding to do differential privacy research has already spoken or will speak. And so the idea of me kind of trying to tell you what somebody else has done when they're the expert and are talking about it for an hour is like on the order of terrifying for me. So I'm not like that. That's just not going to happen. And so I'm going to construe this rather broadly, I guess. So two different pieces of background. If you're not familiar with DARPA, it's DoD's kind of Department of Defense's kind of high risk, high reward research. The kind of tagline is preventing technological surprise. The idea is we try to do research in technologies that we believe will be transformative. And then I guess the second part, just by way of background about myself, so I'm a cryptographer by trade, and then I was at Rand Corporation for a couple of years doing cybersecurity policy analysis, so I guess it's kind of a fun place to be where we fund research. So, okay, this says cryptography. This might as well say privacy. I hate it when people use these things interchangeably, but I just did, so fine. We've basically done, we've been doing programs as in the kind of privacy domain for about, I'm going to mess this up, but something on the order of 10 plus years. We started with Proceed, which talked about computation on encrypted data. Safer was actually built a lot of the pluggable transports for Tor, or started some of that work. I shouldn't say we did them, that it was a whole kind of thing, but it was all about doing resilient communication over the internet. Brandeis is about building privacy-aware systems. Safeware has something to do with software obfuscation. I just took that one over this week, so it's been kind of fun. Man, that was actually why I was really hoping to be here for the whole week, but we had our PI meeting for that Monday and Tuesday. And then Race is about a new program that I started about secure distributed messaging in contested network environments. Think country scale places where it's hard to communicate. And so I'm not really going to talk about all of them. I'm just going to talk about these two. Though now that I kind of understand all the work that we're funding under Safer, I should point out that Dan Bonnet, as part of Safer, has done some incredible work in privacy. There's a work called PRIO, which is about how do you do kind of basic statistical analysis on encrypted web browser telemetry information that has been prototyped in Firefox and hopefully will actually see wider use in Firefox. And then another one, I'm going to mess this up, is Fidelius, which is got accepted at Oakland for this coming year, and answers this kind of wonderfully paranoid question as to how can I prevent malware on my computer from doing keylogging for logins and passwords. And what they literally do is they put hardware between your keyboard and your computer and between your computer and your monitor, Raspberry Pis. And as you do keystrokes, it literally, it assumes the presence of a secure enclave like SGX and pretends that SGX is secure. What it does is it encrypts your keystrokes as it leaves the monitor. And then forwards it directly to the secure enclave up to a different place in the cloud where the website can then access it. And then it actually hacks the HDMI signal to decrypt it on the back end and then actually show it up on your monitor, which is just kind of awesome, just for those of you into that kind of thing, and I am. So I'm really excited about those two works. I'm not going to talk any more about them today. And so really the point is to talk about some of the work we do in Brandeis, explicitly not all of the differential privacy work, which is substantial. So if you hear Ashwin or Michael or Jerome, I can't believe I'm going to actually try to name all the names, or Katrina or Christine, and I'm definitely forgetting, or Dawn, all of, parts of their research are funded under our work, and really, really exciting work at that. So I'll talk a little bit about what Race is intended to be, and then quite frankly, what I'm most excited about talking about today is about the future and where we should go. And the tagline for that is, Brandeis is ending in a year, and I'm desperately trying to figure out what we should be doing moving forward. Okay, so what is Brandeis? Brandeis is, can you have your cake and eat it too? Like, it's really about building privacy-aware systems. So can I actually, can I empower a user to make the decisions they want about privacy? Can I build the systems that actually implement the user's desires as regards privacy? And kind of how far can I get? We're organized, everything at DARPA is organized around like technical areas or TAs. Basically think of that as kind of research focuses that, anyhow. TA1 are kind of these underlying privacy-preserving techniques, so specifically differential privacy and secure multi-party computation, or computing on encrypted information. We do human, really excited that we're doing some really awesome work in human data interaction. So just because you say you want privacy doesn't mean we have any earthly idea about how to implement it. We have to have a real communication. My favorite story for that is back in the day when especially Android users would download the encrypted messaging app Signal, it would say, you know, I need your contact information. And a lot of people who download Signal are privacy-aware people. And they're like, why do you need all of my contacts? This is not a thing that I'm going to give you. The reason that Signal needs your contact information is to be able to very quickly infer who it is that, you know, who else is using Signal. But they don't say that, right? So like we need to be able to build mobile applications that very, very quickly inform you what of your data they are using and why they are using your data, right? So that's research that we're currently doing, mainly at Carnegie Mellon. We are building 3 different experimental integration platforms, which is basically to say 3 major use cases: coalition information sharing, mobile systems, so mobile phones, and what's the third? Oh yeah, Internet of Things. Really smart buildings. We're going to talk more about that. I'm super excited that you heard Sharad speak yesterday, so I don't have to kind of. I think that built a certain intuition about what we're dealing with in that space. And then we're trying to measure privacy, which is just insanely difficult because it's really hard to define privacy, let alone measure it. And so I don't even think I'm going to begin to talk about that today. So, OK. So one of the things that we've done is actually well, the name is at the very least motivated by NSA developed SE for Android, security enhancements for Android. This is privacy enhancements for Android. We've basically developed a version of the Android operating system that is explicitly designed to, in a very fine-grained fashion, control how applications gain access to private information on your phone. So these things are called PALs, which I'm always forgetting what it stands for. It's something like privacy assistance layer. I never remember it. But the upshot is it basically, any time that an application wants to access one of these things, it has to go through this. And in particular, if you haven't given it that access, they won't get it. And it will catch if a application is trying to gain access in a way that was kind of untoward. Interestingly, the other upshot is we can actually turn off access beneath an application. So an application might want your location, and you have the ability using this to say no, which I think is kind of fun. So yeah, this is running on a phone right now, which means it's kind of real. And actually, the team that's developing this, which is BBN and 26 Labs, have been really impressive in their ability to track current Android updates as they occur. In fact, some of the more recent versions of the Android operating system actually make it easier for us to do this. Okay, so that's just one version, and I really, I think I really hope this kind of gets adopted in some fashion. Our goal is to open source this, and frankly, our real goal is I would love if Android actually released versions of this. Okay, so this is another thing we're doing. This is, you see aid stations on the left. A person has a particular ailment. They need to get routed to an aid station. Can I do this while keeping the actual nature of my ailment encrypted? Can I do this while actually keeping the various statuses of the aid stations encrypted? And the answer is yes, and we can do it, and there it is. So that's fun. I'm just kind of basically showing, this is kind of like my bag of tricks. I'm just kind of showing like various things that we're doing just to kind of give you a sense of the nature of the work that we're involved in.
These are part of which of the programs that you?
This is all Brandeis.
All Brandeis.
So yeah, so everything is, this is, Brandeis is, it's a very large program. I think we have, I'm going to mess this up. It's 15 different major performers, I think is what we have, and then associated subcontractors. So it's a 4.5-year effort. We're at our 3.5-year mark. I'm not supposed to tell you how much it's funded for, but Epic FOIA'd us, so you can look and see. So yeah. So this is something that gets at, so this issue of kind of when you ask people why you want their data, CMU has come up with so let me back up. There's something that I always love calling the MIT pizza study, and I just Googled it, and it's actually real. Basically, a bunch of researchers, Stanford economists in fact, went up to a bunch of MIT students and said, we want the contact information on your phone. And the students said, no. Or some percentage of students said no. And then they said, OK, we'll give you pizza. Now will you give it to us? And the answer was 50% more said yes. Which means that like, what it basically means is that our kind of, we say we want privacy, but our barrier for like giving up that privacy is embarrassingly low in some cases. And so how do we actually do better human factors measurement of what it really means for it to be private? One of the things that CMU is actually doing, so this is an example of a study they've run, and they're running a number of other studies like this. As part of their SciLab, they've actually, they basically track people all the time. Participants, obviously, witting participants, paid witting participants. When you show up at a coffee shop, you, for instance, get, it seems like you've walked into the La Prima Espresso business. Cafes like this have started to use surveillance cameras with anonymous face detection software. The software is capable of estimating the number of customers in line in order to optimize operation, or like how okay with you is this. And the idea is that instead of just kind of asking you this abstract question, it actually waits until you're in the place where these kinds of things occur and then present you with a realistic scenario. And the idea is to try to drive the realism to a better, more realistic response. They actually also pay you if you answer faster. So like if you answer there, they'll pay you more than if you answer at the end of the day, kind of thing. So that's kind of one way we're trying to get around this kind of contextual issue. I will say they're about to run a fascinating one. I guess I shouldn't scoop them, so I'll just say on an emerging technology. And what will be fascinating is actually to see the responses change over time, because I would imagine in the first couple of days, people are simply going to be like, I had no idea this was possible. And then once they realize it's possible, their answers are going to be different. So that will be kind of interesting. All right, so that's been in the mobile domain. I'm going to talk now about the coalition information sharing domain. So this is just kind of, one of the things that we're doing is trying to figure out flexible ways of letting coalition partners reason about how exactly it is they want to share information. You know what, I'm honestly not going to talk too much to this. I don't know how this is kind of neither here nor there, I guess, for the purpose of this audience. But this I really like, in the sense that imagine you have 26 countries with 10 different ships, and they want to park at 10 different ports for the purpose of giving aid to a country. What they don't want to reveal is the location of their ships, the speed of their ships, the displacement, all that other fun stuff. So how can they do this kind of collaborative route allocation? And so we can do that in, I think it's like 7 seconds. Again, this is, for those of you kind of familiar with the notions of MPC, the way to think about this is what we're trying to do is take not terribly academically interesting cases of MPC, but implement them in real settings to try to actually make a difference. And that's really what Brandeis has been trying to do. Yeah, I'll leave it at that. Okay, so right, that's kind of what it looks like. Over there. Okay, and then we get to we get into the work that Sharad is doing over at UCI and that team associated. So I should mention, of course, that in each of these settings, what you kind of have is, what Sharad is essentially an integrator. So in other words, they've developed this architecture for IoT analytics, and then we have a number of performers who are working to try to privatize that, including some folks in this room. In particular, it turns out that they can use Wi-Fi handshakes to do geolocated social networks, so who's with whom and when. And they're deploying this pretty broadly around the UCI campus. I love that the kind of main initial application for this was how fast can I get a cup of coffee on campus? Did Sharad already talk about this? Yes, no? Okay. So in particular, it can see where are you by virtue of looking at the Wi-Fi handshakes. It could figure out how many people are at your particular coffee place. Therefore, how packed is it? And so it can kind of route you to the right place given real-time analytics as to how many people are actually there. This raises a number of privacy questions. In particular, who's with whom and when is a totally, how to put this? The semantics of the data is unchanged with regard to whether or not it's us in this room right now or it's students in a dorm room at 2 in the morning, right? There's no difference in terms of what that data says, but the underlying privacy content of that data can change enormously, right? And so how do we begin to think about what that means? It is kind of one of the things that I think Sharad's work has challenged us with. So that's another way of saying that the privacy value of large data is very hard to infer just at a semantic level. I'll give you another example. So we just recently started funding a professor here at Berkeley who is a great guy. We walked in, he said, not that it matters whether he's a great guy or not, I just said that, whatever. But we walked in and we asked what his research was, and he said, we're improving access to microloans in the third world, which is what he is doing. And in particular, in parts, specifically in Africa, essentially the main infrastructure they have is mobile phones, cell phone infrastructure. Okay, so like think of like M-Pesa if you're familiar with that kind of technology. So what they want to do is be able to give microloans. One of the issues associated with loans in general is credit scores. And so what he figured out how to do was how to infer, he can infer credit ratings via cell phone metadata. So that's an example, or wealth for that matter, actually. And it's like country specific, but you can basically use machine learning to do that, and he's demonstrated this in a number of countries. That's an example of data that has a certain amount of value, or a certain amount of privacy content, and then by virtue of analyzing it in a different way, is shown to have a different content that we had no idea was possible. And so how do you deal with the underlying privacy in these settings? I kind of have like a lot of these stories at this point, and that's really where we are, right? Being able to do Wi-Fi handshakes, cameras, we can infer things, mental health status. Carnegie Mellon University is currently using cameras in some of their classrooms to infer how many students are sleeping during lectures. But that data can be used in any number of ways. And the notion of consent or utility is very complicated in these settings, where it may be that they only ever intended to use the data in one way, but due to any number of kind of information sharing agreements or other kinds of things, it could have completely broad implications in any number of other ways, right? And so this is kind of what we're facing. I will say some of the work that Sharad has done, which I think is really cool, is securing data at that kind of scale is really difficult. So we are figuring out how to apply differential privacy to this kind of string data setting, how to even do kind of bulk encryption, and whether it's possible to do processing on this information while it remains encrypted. As you can imagine, that's pretty hard to do, though I don't think it's impossible. Okay. So those are kind of our three main areas. Let me tell you about two different other things that we are currently doing. One I'm really excited about in the sense that I'm not funding it, but it means that it's actually been used, so in other words, like the best thing about DARPA is sometimes like when we develop technology and someone else actually wants it, right? Because that's like that's our main win. And in this case, a nonprofit who I don't think I can name, but has basically hired Galois to do. So for instance, if I want to do better policy related to juveniles, right? And I want to, for instance, understand what the relationship between juvenile mental health and juvenile incarceration is. That would mean I have to have access to both pieces of data. Depending on the state you're in, or just generally speaking, co-locating that information is complicated. So what if I could take the information, encrypt it, and then run the computation to basically create create aggregates, which we then decrypt, but I never actually hold the individual information. So that's the thing basically speaking, we can do. They are doing it. Because the contracting isn't fully finalized, I should say, there's another team that will be doing that, and they'll be on contract in like 3 weeks. Also doing it for child. Specifically, there's a state that has like an on-the-books legal requirement to do an analysis on how they treat their children, how like the state treats the children. But again, they also have laws that state that they cannot co-locate information. And so we'll be using encryption to try to figure out, to try to solve that problem. And so, put another way, I think that in at least some cases, these kinds of kind of homomorphic encryption solutions can be used to do better policy-based analysis. Again, the other way to do this, of course, is to make sure everyone has all the access to all the things. That's certainly a way that you could do it. That is hard for a variety of reasons that I think a lot of people in this room appreciate. Here's another one. We're looking at the state of Virginia and trying to look at outcomes related to their college system. So in other words, what's the value of a college education in the state of Virginia? In order to do that, you kind of need to co-locate a lot of information about salaries and loans and all sorts of other fun stuff. That's hard, though not impossible to do, as there's at least one person in this room who's doing it completely unencrypted, which is awesome. So we're trying to, again, do this over encryption. Here's just like a random smorgasbord of all the different technologies we're kind of underlying to do this. Scale Mamba is an open source tool to do secure multi-party computation. We're doing some work on SGX. I'm really excited that we're also doing some work in something called Sanctum, which is Srini Davidas is doing. It's like an open source secure enclave for RISC-V architectures. Functional secret sharing is cool in the sense that it's a very specific technique that lets you do updates to extremely large encrypted databases with the size of only a couple of AES encryptions. So it's kind of a, for those who would care, it's a really hard thing to do, and it enables us to, for instance, update an entire encrypted map in kilobytes, which is very, very hard to do. So I'm not going to go over all the DP work. I believe a lot of this has been talked about. I don't even know why I put local DP as like its own bullet point, but I put these slides together in not enough time. So, okay. Yes, and this is just one example of the open source tools that we have. There are many others. All right, so that's that. Let's talk about a different program. So this is about privacy, but in a very different way. So this is like more closer to the privacy as confidentiality. How much can I lock down information given a particular kind of use? So race is about. One second. Clearly, I need to mute something. Okay. Race is about, could we use cryptography and obfuscated communications to build an anonymous and attack-resilient mobile communication system that can reside completely within what we are calling a contested network environment. Again, think here country-sized area. So the idea is, so just to step back, Tor is an amazing technology. Tor kind of relies upon, so Tor is an ability to anonymously access the internet. And it relies upon thousands of volunteers distributed globally, and it kind of gains its resilience through its living kind of everywhere. The problem with Tor is that it has to announce where it lives. And because it announces where it lives, countries block it. So there are many countries where Tor, essentially speaking, does not work. And so what we're trying to do is to try to basically say, okay, fine, could we actually build a distributed presence completely in some locked down environment that actually doesn't know enough about itself to be targeted, and yet is able to do the most basic functionality, which is messaging. So we're not being nearly as we don't think we can do internet scale, actually internet access. That's much harder, especially because it involves like sessionization, which would be pretty hard to block from a NetFlow perspective or to obfuscate. So roughly speaking, imagine you have a bunch of guys who are folks who are just volunteers, and then you have Alice want to send something to Bob. And the rough idea is that not just that the message itself will be encrypted, so end-to-end encryption, thankfully, is essentially a fact on the ground right now, but the addressee will also be encrypted. And the system will compute on the encrypted addressee in order to figure out how to route it to that addressee using secure multi-party computation. As lightweight as possible secure multi-party computation. Yeah, this is all about, it would be really cool if you built this highly distributed thing, but if it's rolling like custom crypto, it's gonna get spotted a mile away, and they'll just block it, right? So how can we do this in such a way where it's actually not blocked? So that's the kind of two main tasks. Yeah, I'm gonna leave that. Our security properties are pretty extreme in the sense of end-to-end encrypted messaging, full metadata security, and ideally unobservable. And unobservable means if you're not actually sitting on a system running it, so if you're not like literally on a phone that's running this or on a network node that's running this, you shouldn't be able to infer via just kind of looking at its communications whether or not it's actually running the system. Because that's about the only way I can think of that this might possibly work in difficult places. Okay. Yeah. So it's basically broken up. TA1 is going to do the underlying cryptography. TA2 will do the communication links. TA3 will be their actual integrators. And we're building we have a separate team building out a large-scale testbed in order to try to figure out whether this is actually going to work. And this kicks off in May, we hope. Contracting is currently in place. I'm not going to say too much about this other than the goal is essentially to do 1,000-party secure multi-party computation at scale over hidden communication links, over specifically 10 Mbps links, which is aggressive. So we'll see whether we can do it. Again, our hope is that because the underlying functionality is so basic, in other words, you basically are just parsing where is it trying to go and how do I allocate. So it's essentially coin tossing, not much more than coin tossing. And then it might actually be possible at that kind of scale. We'll have to see. Where am I on time? Oh, good. Okay. So what is coming up? I'm like as open as possible in terms of the things that we're doing, and this is a I'd like to tell you you're the first to hear this, but I've been telling this to absolutely everyone. The program that I'm building is on something called zero knowledge, which is oh god, saying this in front of Shafi is kind of funny, but okay. The idea that basically how can I prove to you something without revealing the underlying encrypted inputs? Right? So in other words, can I prove that I know a secret key without saying that? Can I prove that I have a certain monetary value or anything on that order? So how, that's been known that we can do this since the 80s. I kind of am coming at it from a bit of a different place, which is, there are two different things. First is that the last 5-ish years have seen extraordinary growth in zero knowledge technologies, largely coming out of cryptocurrencies. And those are, think of those as low complexity, very high rate zero knowledge proofs. What I'm interested in is far more complex and therefore slower. So like, can I do really complicated things in a day? So as an example, could I reason about software in zero knowledge? Could I give a zero knowledge proof of security or insecurity in zero knowledge? Could I, a lot of the stuff I've been thinking about is, so two different other use cases. One, I've been in a lot of rooms where people talk about fake news, and all they want to do in life is to lock down all of the, like, for every piece of information on the internet, I want to know where it came from, right? That has like extraordinarily bad implications from a kind of freedom on the internet scenario, right? If someone takes a picture of a protest, we shouldn't be able to know who that person is, right? Necessarily, at least. So can I give zero knowledge proofs of integrity of digital information without actually revealing, information on it? I think is it's not like we don't need zero knowledge proofs to do that, but zero knowledge proofs could be a very important tool to do that kind of thing. The other is actually how the government kind of communicates about things that it does. So as an example, the US government said that the North Koreans hacked Sony. And then there was a company in the Bay Area that said, no, we think it's not them. Could the US government give us zero knowledge proof of attribution, right? And before you think that's the craziest thing ever, realize that Cyber Command right now is actually tweeting virus total commits that they're making for advanced persistent threats. And so it's not the craziest thing in the world that like the US government would actually release kind of some kind of highly technical information for the purpose of verification, or they're kind of sort of doing it already. So basically, the basic structure of this program, if it happens, and let me be clear, it may very well not happen. It happens all the time that program managers have dreams that that our directors crush. Basically, area one would be actually building NP statements. So in other words, take complicated things in the world and describe them in a way that I can give a zero knowledge proof. So that's not really a cryptography task. It's really something broader, like complexity theory or programming languages. It's something more, and I think it should be really interesting. Anyhow, most cryptographers will just say, given a proof statement, how do I prove it? So I want to ask, how do I actually say the proof statement? That's part one. Okay, fine. Part two is how do I actually prove it efficiently? And then part three, if I have anything to say about it, which I may not, is actually blue sky, like theoretical zero knowledge work. So things like probabilistically checkable proofs, founding better cryptographic stuff on like post-quantum assumptions. So like learning with errors is a common, plausible, post-quantum assumption. Okay, so that's area one. I'm going to skip consensus protocols because, not because I don't think it's interesting, I actually think it's really interesting, it's just not really about privacy. The tagline here is, I think that Bitcoin is essentially an existence proof that economics has a place in distributed computation. So basically, how can we rewrite our understandings of distributed computation to get beyond, malicious and honest but curious into notions of utility, which kind of sort of already exist in basic forms in cryptography, but I want to lock cryptographers and computer scientists in a room, and economists in a room and create new distributed computation frameworks. So fine. That should be all kinds of fun for any number of reasons. All right, so this is like a terrible slide, but I'll try to talk to it. So basically, so this is, Brandeis is going to end in a year. And So I didn't create Brandeis, I took it over. John Launchbury created Brandeis. In fact, I'm actually the 4th program manager in 2 years for that program, which is super weird, but only because 2 of them had like really great things happen to them and moved on. And so I just kind of was, the guy they brought in. But the question kind of is, what should DARPA's role in privacy research be? And so I kind of want to start these thoughts in kind of two different places. The first is that our role is really to be transformational. So if it sounds like it's evolutionary, if it's kicking down a particular, if we're just kind of, we know we can do a thing and let's just push it a little further, that's really not what DARPA is here to do. That's not our purpose. So it's really what is the thing that totally might not work that we could do. And the other is, the one thing that Brandeis isn't really addressing because it's really hard and we were never set up to do it is privacy and big data. And so that's kind of what I've been thinking about in terms of where we should go. And I have 2 different thoughts, and then I'm probably going to leave it to see. Yeah, man, this slide really doesn't say anything. The 2 things I've been thinking. So the underlying, kind of the thesis is that we are living in a persistent surveillance environment right now. Everyone is collecting all of our data all the time, and they're sharing it and computing on it in ways that are both expected and very unexpected, in ways that are not adversarial at all and highly adversarial. I just would claim I would claim that it is essentially impossible to measure the underlying privacy content of the data that's collected about us. There are kind of 2 different paths I think we could take, one of which is much more likely than the other. So the first path is, how do I simply cut off the data flow? So in other words, how do I empower the average American to be a digital ghost in a big data world? Could I have a mobile phone that was perfectly useful and yet perfectly invisible to those who actually collect the information about it? I think it's technically doable, but hard. And I'm not sure if it's doable in a foundational way, which is to say we might have tools to do it today, but then it's kind of like a tit for tat in terms of other large companies would probably figure out ways to defeat it, and then you kind of have to go back and forth. But it's enormously important, both at a societal level and frankly for the US government. Oh yeah, I should probably say a second thing about where this is coming from. I think we're really getting to a place where privacy is not just about someone, knows my social security number and they really shouldn't. Someone knows my health and they really shouldn't. It's like, that sucks for me. I think where we're getting to is there are countries in this world who are using the same technologies that we think of in a kind of aw shucks way for like country scale social control. Like this is occurring right now, specifically in China. I think that privacy, what has been an important area is only getting more important. And I think DARPA's role is to combat those uses. And to retain, to let someone have, because we're getting beyond a place where like my ownership of my data is now not just an issue of, something about me that I don't want you to know, but you have actual leverage over me in a way that I'm not okay with. So like teachers in some American states having to wear Fitbits so that their health insurance knows what they're doing. That's just the start of it. Think of all of, and I don't mean to be like sitting up here and like, Sturm und Drang or whatever, but, think of the work that Charade is doing at a large scale and then used to infer things about you. And then kind of, especially when you build it into like a social credit score, which then becomes a whole host, So privacy is about making sure that those inputs, one of the things that privacy is about is trying to retain ownership over your inputs into this larger system. Okay, so that's where the kind of need to cut off the data comes from. I honestly, I just can't imagine we're going to do it, but it would be fun to think about if y'all want to. The other aspect of that is, again, so if we make this claim that we don't understand the underlying privacy content of information, the thing I do think we would understand is the privacy content of queries, right? So I may not understand, the kind of global value of, global privacy value of data, but I might understand its local value with respect to some query. And so what if we could build a system that essentially, think of like your AI angel on your shoulder. Basically build a capability that actually resides with data owners that essentially represents you, right? And so when someone wants to access your data within, within some data center, it has to contend with this kind of semi-interactive functionality, which is to say it's interactive with the data owner and it's semi-interactive with you, right? So you upload it, you give it certain privacy preferences that you want. It represents those preferences to the data owner. Frankly, I think it should have the ability to audit the data owner, and then in a privacy-preserving way, but here actually privacy-preserving in terms of how the data owner is using it, being able to kind of do some notion of verifiable computation as to how your data is used. So in other words, to give some actual interactive agency. I have no idea if this is a great idea or not. This is the kind of thing I'm currently thinking about. The other part of that would be on your device or the kind of the source that gives that information, keep on pushing on the human factors in this setting. And making sure that you actually are having a conversation about your own information that is an informed conversation, right? So that's the kind of second. So it's either we cut off the data, or we give you more agency at the site of the information itself. So those are the two areas that I've been thinking about. I think we're at my 10-minute mark. And so really, I want to encourage either, questions on this, but either kind of moving forward from here, I really, please do reach out to me. I've got a little bit of time to figure out what this program should be. One of the cool prerogatives of this job is so people come to me and go oh, well, what are you doing? And my answer is often what do you think I should be doing? I'm not the expert in this stuff, tell me, what am I missing? What's possible that I didn't know was possible? And how can we leverage that to build this, to help folks? So anyhow, that's what we're doing. Thanks.
Question right there.
So you talked about cutting off data entirely, and one thing that strikes me, as somebody at FPF pointed this out to me once, is that there's sort of also a civil rights issue there, and that an access issue, in that if my data disappears entirely, then I'm not represented in the data where people decide what products should be designed, what services should be provided, and so on. So you kind of want the general services to know that me and people like me exist with the needs that I have, but not know that it's me specifically. Just one thing.
I think that's true. I mean, I was talking, it relates to so I was talking to a political scientist at UC San Diego, and she was pointing out that AI, specifically things like AI-enabled social services, also become in and of themselves another means to which authoritarian regimes can in a backhanded way do shifty things. And so I think it's kind of the two sides of this coin of there should be a certain verifiability to all of it, right? So these underlying, anyhow, so yeah, I think it's, sorry, I'm just pointing.
Yeah, both in what you sketched here with the AI privacy agent, and I think you had something like that in one of the early slides where you said there's a privacy manager for the Android version. What's inside that box? I mean, you following Helen, makes the application immediately clear that to measure that, what the preferences are, what the expectations are, what the norms are, it's incredibly difficult.
Yep.
And it's so far I haven't seen convincing implementation of those that try to on the fly write privacy policies based on preferences, and because the way you ask these questions generates a lot of different answers.
So I think you're absolutely right. Essentially all of that work for us is happening at Carnegie Mellon. We're funding a substantial number of the academics at Carnegie Mellon who work on issues of human factors. So there are kind of multiple parts of that. We're doing a lot of human factors experiments. I was really hoping to show you some of the designs, but I actually don't have a really good screenshot of what it is. And we're still experimenting. So an example is, well, first of all, so many different dimensions of this problem. What is the actual thing I ought to be presenting you as a choice, right? So is it do you have access to this location? It actually turns out, or should this app have access to this location? It actually turns out that one of the more powerful access mechanisms is actually asking about third-party libraries that are running on software. So it's a little bit more abstract from a user's perspective, but there are basically their research has shown it's something like 3 or 4 different software libraries that if they're running those, those applications are running are collecting substantially more about you than otherwise. And so turning off, for instance, specifically AdMob actually would be one of the main ones, which is again, there's issues of nudging, and so we're studying nudging within the context of this. We're studying whether if I tell you, do you want to do this particular thing, 10% of your friends have done it, or 10% of users have done it one way versus 90% the other way, if that's more powerful. So that's a long way of saying I don't know, and that's why we're researching it, and I wouldn't pretend to say that we have an answer, but it's certainly of high interest to us, particularly in the mobile domain.
Mine's less of a answer to your call for ideas, and more just a question about the examples of work you showed under current Brandeis were less tightly, or they seemed less tightly coupled to each other than the picture I had in my head of how these programs are structured. And so could you say a little bit about that, and how, how much is it, many teams all sort of working on an integrated thing, or needs to be for...
Yeah, it is highly program specific. There is no one template. Brandeis, frankly, is a little unique. Normally we have one integrator. The way to think of it here is we have 3 different integrators. My understanding is the way this literally happened was they all showed up on the first kickoff day, and it was like, figure out groups and work together now. And it worked. That really shouldn't have worked, but it seems to have. And a great credit to a lot of our, so again, just to back up so it's just easier to see. What I would say is that, getting there, okay. Essentially speaking, especially in the TA1 domain, they just like working, as you probably appreciate, just showing the applicability of this technology is so exciting that if you kind of present people with, would you be willing to extend yourself to a different application space? I know you've been working on mobile, but we have this issue in Coalition. Like, is this interesting to you? And their answer is almost always yes. So that's been really awesome, but Brandeis is pretty unique in the structure. Race has been a lot more single integrator, a lot of different performers. We'll see what flies. Phi will, so the zero knowledge one, sorry, I call it Phi, proofs using hidden information. We'll see if that name sticks, I again imagine it to be multiple. So a lot of people developing NP statements, a lot of people doing compilers and kind of mixing and matching to see how it plays. But we'll see, and so I can't, so that's also much more, to speak, 6.1 fundamental research. So it's not really designed. The point there isn't to build working systems per se. It's more existence proofs. This is the kind of thing we can do. Brandeis was really intended to be like this integration, build actual prototypes. So yeah, that's a really long way of saying it really, really depends.
It's helpful.
Thank the speaker.